Looking at the top of the engine, you'll find the fuel injectors and fuel rail located in between the intake manifold. On this vehicle, you'll find that there's 6 fuel injectors, 3 on each side, and 1 per cylinder. And if you take a look at the front of the vehicle, on the left fuel rail, you'll find a mechanical vacuum-operated fuel pressure regulator. This regulator is what controls the pressure inside the fuel rails and is also assisted by vacuum to help make it more responsive based on engine load. Excess fuel that's released by the pressure regulator is sent back through a return line to the fuel tank.
Taking a look in our wiring diagram here, you can see that we have our power wire that is colored blue and black that comes into all 6 injectors. And with this injection system, we can tell that it is a sequential system because each injector wire has a different wire color, from injector 1 having a pink wire, injector 2 having a pink and black wire, injector 3 having a pink and green wire, injector 4 having a pink and blue wire, injector 5 having a gray and green wire, injector 6 having a gray and black wire. And we see here that injector 1, that pink wire feeds into pin 15 on the PCM. Injector 2, the pink and black wire feeds into pin 34 on the PCM. Injector 3 has the pink and green wire that feeds into pin 14. Injector number 4 has the pink and blue that feeds into pin 33. Injector number 5 has the gray and green that feeds into pin 13. And then injector 6 has the gray and black that feeds into pin 32 of the ECM.
Here I'm checking the resistance of the injector. On this vehicle, the injectors should be anywhere from 11.5 to 12.5. So you can see when I get a good connection that I am getting 12.2, which is right on spec. Thing to note is that this test is meant to be done when the engine is cool because temperature changes resistance. So you could have a hot injector that reads a higher resistance, making you think that it's a faulty injector when in reality it's perfectly fine.
With a Noid light tester, we can see proper function of the circuit when the light turns on and off. Bench testing the relay here, we can see that pins 30 and 87 are functioning normally with an OL reading, and then testing pins 85 and 86 gives us about 80 ohms of resistance. With a scan tool hooked up to the vehicle, we decided to take a look at engine speed, injector pulse width for bank number 1, and injector pulse width for bank number 2. You can see that around idle, the injectors are being held open for about 2.3 milliseconds. When the throttle is increased, the injectors are held for just over 3 milliseconds. And then when the throttle is released from wide open throttle, the injectors are on for a much shorter period of time to just about 0.2 milliseconds or around 1.8 milliseconds. For testing purposes, we decided to unplug the number 3 injector to see what codes we could get. After unplugging injector number 3, we got codes P0171, bank system 2 lean, and then code P030, cylinder number 3 misfire.
Taking a look at our scope pattern of an injector, you can see that when it's grounded, that is the on time for the circuit. And you can see how that on time varies based on engine RPM and load. Basically, when there's more load, it increases the on time of the injector. And then once it hits the target RPM, it will lessen how long the injector is open for. The PCM can also shorten injector timing. For example, when you let off the throttle to cut fuel to the engine until it reaches the desired RPM that the PCM is looking for. When measuring the injector on time, we were seeing about 3.1 milliseconds that the injector was powered on at idle.
Along with our picoscope being hooked up to the injector, we have an inductive amp clamp hooked up as well. So with that gold line, that is the amperage ramp, and you can see it start to ramp up gradually. Straighten out a little bit, that is where the pintle of the injector starts to open. The amperage ramps up just a little bit more, and then drops off. And where the top of that amperage stops, that an imaginary line is right across from that, and that is where the pintle starts to close with the magnetic field collapsing. Here we decided to measure where the pintle was opening inside the injector, and it looks like the pintle opens around 1.8 milliseconds. We measured our voltage spike, and it was around 47.5 volts, which is perfectly normal for this being a saturated switch. And then our amperage going through the injector was around 1.1 amps. Here we have our picoscope set up to look at the voltage drop across the injector, and it looks like we are dropping battery voltage at idle across the injector, 14.32 volts. And so at ground, you still might see some continuity, like around half a volt, or maybe even smaller, like 0.04 volts.